Hello friends, welcome back to Akida. Okay, in the previous videos, we have seen number of problems based on final settlement and finding the wide ratios and finding the time required for the consolidation or finding the different values like compression indexes or volume compressibility or coefficient of consolidation. Now, as of now, we have seen only one clay layer, right? Now let us see here in this problem. There is a structure of the soil structure. Here in between clay layers, it is found that there is a sand layer also, right? As of now, we have seen that only one clay layer is there. So if there are n number of clay layers, in between the clay layers, if there is any other type of soil, let us see how to find out the settlement value, right? So if there are n number of layers, still the total settlement, if I want to find out, that is what nothing but a summation of the settlement in each clay layer, summation I equal to 1 to m. So by seeing this case, how many clay layers are there? Two clay layers are there. So that's why settlement in the first clay layer and settlement in the second clay layer. That is what nothing but your total settlement of this soil composition. Now, if I explain you about the question, there is a soil structure. For that soil structure, it is applied that, and at present, the external stress is applying 75 kilonewton per meter square. And the properties of clay is given and sand is also given. And also it is mentioned that pre-consolidation stress is 20 kilonewton per meter square. Pre-consolidation means before the application of this 75, there is a stress already applied on this structure and then it is removed. Okay. Now let us see how to incorporate that effect. Okay, even the n number of layers are there. If you want to find out settlement in this layer, then you have to find out all the reference values corresponding to the center of the clay layer. That means I have to consider the center of this clay layer. Similarly, in this clay layer, if I want to find out the settlement, again I have to take the center at this clay layer. So this is what I'll call it as a 1 dash, and this is what I'll call it as a 2 dash. Okay. Now let us say this is the part 1 and this is the part 2. Let us say we are going to evaluating the settlement in the first clay layer. So if you see the given data, they are given a recompression index, also they are given compression index. This is how we have to check this about the pre-consolidation stress. As we know the initial void ratio or compression index, then by using which formula we can find out the settlement? By using this settlement, that is nothing but a H naught into Cc divided by 1 plus E naught into logarithmic final stress divided by initial stress. Right? Now, as our soil structure is completely subjected to the pre-consolidation pressure, let us say this pre-consolidation pressure is sigma C. So, if your initial effective stress, that means if your initial effective stress is less than this pre-consolidation pressure, then the soil is again going to be compressed. That means we are talking about the pre-compression value. If this is greater than sigma naught, then we don't have any problem, just like we have discussed in the theory. Okay. Now let us just first concentrate on the first layer. Right, this is the first layer. If I want to find the settlement, I have to take at the center of the clay layer only. So if the total thickness of the soil is 2 meter, then what about the 1 meter? So what about the initial effective stress at the center of clay layer? 1 into what will be the effective value? Gamma saturation for the clay. How much it is given? 20. Okay, for the simplified purpose, let us say gamma W consider it as a 10 kilonewton per meter cube. It is nothing but 10 kilonewton per meter cube. So 20 minus 10. So how much it will be? 10 kilonewton per meter square. What about this pre-consolidation pressure? Already it is acting as 20 kilonewton per meter square. As this pre-consolidation pressure, it is greater than the initial effective stress. That means recompression is happening. So if I represent the value, what is the least value? Initial value 10, after that 20. So what is the stress? It is increased. How much effective stress, or what is the surcharge you are applying on the problem? 75 kilonewton per meter square. So what about the final value? Sigma f dash. That is due to the initial plus change. What is initial value? 10. What is the surcharge? 75. That will be equal to 85. So that implies 85. As the pre-consolidation price is already 20, in between these two, we have to apply the decompression index. From 20 to 85, we have to use the compression index. So if I rewrite the formula, in between 10 to 20, this will be nothing but your sigma naught. This will be nothing but your sigma f. Again, in between 20 to 85, this will be nothing but your sigma naught, and this will be nothing but your final stress. So if I express the equation, settlement in the clayey layer 1, that is nothing but a final thickness is constant both the layer divided by 1 plus E naught times. For 0 to 10 to 20, we have to use the recompression index into log of sigma decompression stress divided by initial stress, plus after sigma c compression is happening, Cc, into log of what will be your final effective stress divided by pre-consolidation stress. That's it. What about the H naught? 2, 1 plus, what about the void ratio? It is directly given in the problem. How much it is? 0.87 into recompression index. How much it is given? 0.03. 0.03 into log of pre-consolidation stress 20, initial effective stress 10, plus Cc is given as 0.28 into log of final effective stress. It is obtained as 85. Pre-consolidation stress 20. That's if you solve this, that is what nothing but your settlement happening in the clay layer 1. Now just solve these values. Just hold on a second. Let me solve this. So if you solve this, we are getting these values around 0.197 meter. Okay, this is what the settlement happening in the clay layer 1. Now talk about the settlement happening in the clay layer 2. Okay, now if I again represent the values here. So as again we have to consider the center of the clay layer. So from here to here it is nothing but 2. This is a sandy layer 1 meter, and again as the total thickness is 2 meter, center it is nothing but 1 meter. Okay, what is the pre-consolidation stress is given? 20 kilopascal. Let us find out what is the effective stress, initial effective stress. That is what nothing but in this clay, that is nothing but 2. For clay, what is the saturated weight? 20 minus 10 plus in the clay layer 1 into, for sand it is given as 22 minus 10 plus 1 into 20 minus 10. This is what about this layer. That implies what will be your initial stress. So if you solve this, we'll get 10, 20 plus 10, 32 plus 1 plus 10, 42. That is nothing but a 42 kilopascal. As you can observe here, pre-consolidation stress is less than the initial effective stress. That means here pre-consolidation is not happened. So that implies how can I find out the final settlement in the second layer? Directly by using H naught into Cc divided by 1 plus C naught into log of final effective stress divided by initial effective stress at the center of clay layer. Already we have found what is the initial effective stress at the center of clay layer? 42. Then what about the final initial plus what about the final values? 75. That implies how much it will be? 42 plus 75. That is what nothing but 117 kilopascal. That's it. Substitute in the equation. H naught is 2 and the compression index is given as 0.28 divided by 1 plus the void ratio is given as 0.87 into log of final value we are getting it as 117 divided by initially we are getting it as 42. So if you solve this, we'll get this as around 0.133 meter. So this is what the settlement happening in the second layer. So whatever the total settlement of the soil structure, that means settlement happening in the layer 1 plus settlement happening in the layer 2, that will be equal to, in the layer 1 the settlement is going to happen 0.197 meter, 0.197 plus 0.133. If you are adding, you will get it as, we'll get this value is around 0.33 meters. So in the present problem, we have considered, by considering different layers of clay structure. So in the present problem, I have given 2, but in the exam, if by giving every data, they may give you 3, they may give you 4. So if there are more than clay layers, just find out the settlement in each clay layer and then add the values. And in the present case also, we have seen an example that how to consider the pre-consolidation stress also by considering the recompression index. So with this, we can say that all variants of the problems are considered. Just before substituting the answer, we should take care of in which unit we have to substitute. Okay, this is what about the problems on the consolidation. In the next chapter, in the next video, let us start the new chapter. Thank you.